Good afternoon, students. In today's topic, we are going to discuss about grade 10 chemistry, study of compounds, ammonia. See, many students have asked doubts about this ammonia. So, in this topic, we need to concentrate about 8 subtopics. That is, occurrence, preparation of ammonia gas. We have again two methods. First one is general methods. Second one is laboratory preparation. In that we use ammonium chloride, and second one is metal nitride. So what do you mean by nitride here? Nitride means N3 minus ion. When it combines with metal, you will get metal nitride. Third concept, preparation of aqueous ammonia. Then industrial method, that is manufacture of ammonia using Haber's process. Fifth topic, physical properties, and then very important, we need to discuss about chemical properties of ammonia. We are having 7 chemical properties. So I have listed them like this. Number 1, thermal dissociation. In presence of heat, what will happen to ammonia? Then basic properties. Then burning ammonia in oxygen, catalytic oxidation. And reducing agent, we know ammonia is a reducing agent, so what are the chemical properties? Then sixth one, reaction with acids. And seventh chemical property, reaction of aqueous ammonia with soluble metal salts. And then we need to discuss about the test for ammonia gas as well as ammonium ion. Now eighth and last topic is, what are the uses of ammonia? And I have added these two things, number 9, that is previous year questions, and then finally you will be given the revision test on this topic. Hope you have understood this. Now let us move on with the first topic, that is occurrence of ammonia. Now if we see the molecular formula, ammonia is represented as NH3, and molar mass nitrogen 14 atomic mass, and 3 hydrogens plus 3 we get 17. Now if you draw the Lewis diagram, atomic number of nitrogen is 7, so configuration is 2, 5. So always remember that the valence electrons are represented as Lewis dots. So here how many dots we have to write? We have to write 5. So this is 1, 2, 3, 4 and 5. So this will not participate in the bonding, hence you call it as lone pair of electrons. And hydrogen, atomic number is 1, so therefore it has 1 valence electron. We represent that single electron like this. So 3 hydrogens with the electron here. Now there is a covalent bond formation, and you call it as bond pair. This is bond pair and this is also bond pair. So we can observe that in ammonia structure we have 1 lone pair of electron and 3 bond pairs. Now coming to the occurrence, we can see 5 types, like we can observe nitrogen in the combined state. NH3 plus HCl will form ammonium chloride, and you can get ammonium sulfate also, and here ammonia exists in the combined state. Now dry ammonia gas we can have. How do you get liquid ammonia? At high pressure, if you take dry ammonia gas, you can liquefy that. Now fourth one, liquor ammonia fortis. This is nothing but saturated solution of ammonia in water. So you can also call it as 880 ammonia. Now the last one is dilute NH4OH, that is ammonium hydroxide, nothing but NH3 plus H2O. This is used in our laboratories as a bench reagent. Hope you have understood. Now let us move to the preparation of ammonia gas. Now the general methods of preparation of ammonia gas. See, we need to remember the general equation. So what is the general equation? Always if you remember this, you can take n number of examples like this. So ammonium salt with alkali, what is meant by alkali, right? So water soluble base. So example for alkali, you can take calcium hydroxide, sodium hydroxide, potassium hydroxide. So on heating that, you get salt plus water and ammonia gas is liberated. So hope you have understood this. Ammonium salt with alkali on heating gives salt plus water, and the required product ammonia gas is produced. First one, take ammonium chloride. So here you know that from here ammonia gas is liberated. So what else you are having? Cl minus Ca2 plus. So these two will form calcium chloride salt. So along with that you have water and ammonia. Second example, if you take ammonium sulfate, so sulfate is the anion here and calcium is the cation. So therefore what is the salt you get? Calcium sulfate. So other products, water and required ammonia is liberated. Next, if you take sodium hydroxide as alkali, sulfate anion and sodium cation will give the salt sodium sulfate. Then apart from that, usually you get water along with the liberation of ammonia gas. Now the last one, if you take potassium hydroxide as the alkali, now anion is sulfate, so once again the salt you get is potassium sulfate along with water and liberation of ammonia. Now next we will see the laboratory preparation of ammonia. Now if we see the laboratory preparation of ammonia, already we have discussed that we have two methods. Number one, using ammonium chloride, and second one is metal nitrites. So let us see the first method. You can write down like this, it is easy for you to remember. What are the reactants here? Because you know it is from ammonium chloride, the first reactant is ammonium chloride and we are adding alkali calcium hydroxide. So previously we have seen this. So ammonium salts with alkali, so ammonium salt with alkali on heating gives salt plus water plus ammonia gas. So in the general methods already you have seen the equation. So same thing. Now what is the procedure here? We have taken in a round bottomed flask calcium hydroxide and ammonium chloride and you start heating this. So in the other end of this is connected to the glass tube where we have in this vessel calcium oxide. So what will happen? The reaction says you are getting NH3 gas, also some water vapor is also released. So what is the role of this calcium oxide here? The drying of ammonia gas. So calcium oxide or quicklime has the tendency to absorb the moisture. So here the water vapor gets trapped out. Now what is released out through this NH3 gas, dry NH3 gas is passed out and you can collect it. So how you are collecting this? So the collection is downward displacement of air. That means whatever air is there, that air will settle at the bottom. So downward displacement of air. Why it is so? Because ammonia is lighter than air. We can see this. Vapor density of ammonia is 8.5, but vapor density of air is 14.4. So therefore ammonia will be like above the air. Now one important precaution here, what is that? You have to tilt this flask. Why you have to tilt this flask? Because so the water is formed. So on heating the water is formed and it should not come back. So if you keep it in the vertical position, what will happen? The water may come back, and because it is heated flask, the water will break it. So due to that we have to have this in a tilted position such that the water will not come back and break this flask. That is the precaution. Now one more important thing you have to observe here. Why you are using only calcium oxide? Why not the other drying agents? So we know that the drying agents are concentrated H2SO4, phosphorus pentoxide, anhydrous calcium chloride. So what is the reason we are not using? Because they all will react with ammonia and gives the product. First case, H2SO4 with ammonia forms ammonium sulfate. P2O5 will react with ammonia and forms ammonium phosphate. And the last one, calcium chloride also reacts with NH3, but this is forming addition product. So because of their reactive nature, the other drying agents are not used in this process. So only calcium oxide cannot combine with ammonia, that's why we are using this. So hope you have understood. With this we have completed the preparation of ammonia in the first method. So we need to see the preparation using metal nitrides. Now the second method we'll discuss, that is from metal nitrides. See, you can take the general equation. What is that? Metal nitride with warm water gives metal hydroxide and ammonia gas. So don't forget the general equation, because we can take a number of examples using general equation. Now first one is magnesium nitride. How did you get this? Magnesium oxidation state is +2 and nitride is -3. So you know crisscross method. So therefore formula of magnesium nitride is Mg3N2. Second example, aluminum nitride we can take. Aluminum oxidation state +3, nitride oxidation state -3. So if you take crisscross method, you can cancel 3. So you get AlN. So hope you have understood. First one is magnesium nitride. Second one is aluminum nitride. Now with the warm water, you will get magnesium hydroxide. Here you will get aluminum hydroxide. Along with that, ammonia gas is liberated. So this is about your reaction. Now what is the procedure? So in the flat bottom flask, we have taken magnesium nitride, and using a Thistle funnel, you can add warm water to this slowly. So dropwise addition you can take. So water will be added to this. Now the reaction forms. So ammonia gas is produced, will pass through this delivery tube, and in the center, once again you know you have to take the drying agent. Why you take drying agent? If some amount of moisture is there also, it will be trapped into this. Now here ammonia gas is collected over here, and once again by downward displacement of air. See, the collection and drying agent, everything is same like what we have used in ammonium chloride method. So hope you have understood this. Very simple. Metal nitride with warm water gives metal hydroxide and ammonia. Two examples you can take. So next class we will continue. Thank you so much.